In high school algebra, one of the really useful things you learn is about expressions with variables in them. So things like x squared plus 1. So that's an expression which doesn't have a numerical value yet, but if you substituted in a numerical value for x, then you would get a number. We're going to do a similar kind of thing in logic. Specifically, we're going to introduce expressions to represent complicated propositions obtained by combining simpler propositions using our connectives. Those logical expressions are going to be called well-formed formulas. And just like x squared plus 1 doesn't have a value until you substitute in a value for x, our well-formed formulas won't have a truth value. They won't be true or false until we decide on a truth value for the propositions which made up those well-formed formulas. Let's think about the ingredients that we're going to use in our well-formed formulas. There are 3 different things which are going to go into a well-formed formula. The first thing is a propositional variable. So a propositional variable is a variable that can be true or false. And throughout Math 5, we'll write T for true and F for false, like this. The usual symbols for propositional variables are lowercase English letters, usually starting with P on Q and R. The next ingredient for well-formed formulas is symbols for the connectives, which we discussed on the previous video. So we talked about the English language connectives and, or, not, and implies. And we have a symbol for each of those connectives. And is represented by this wedge symbol here, or is represented by this V-shaped symbol, not by this thing, and implies in Math 5 will be written with this arrow, but if you read other mathematical texts, you'll sometimes see just this arrow used for implies. The final ingredient is that we use ordinary round brackets like this in our well-formed formulas. Okay, so a well-formed formula is not just any collection of propositional variable symbols, connective symbols, and brackets. You have to obey some rules in order to make sure that what you have is a meaningful logical expression. It's a bit like what happens in natural languages, right? There are lots of English letters, A, B, C, and so on up to Z, but not all combinations of those letters makes a legitimate word. Like if you have B, X, V, Y, Y, Z, as far as I know, that is not a meaningful English word. So we have some rules which tell us which collections of these symbols make a formula to which we can give a logical meaning. And those rules are on this slide. So we're going to define on this slide exactly what is and what isn't a well-formed formula. And we do that using 2 rules. So the first rule says that a propositional variable on its own is a well-formed formula. And the second rule is that if you have 2 well-formed formulas, phi and psi, then brackets phi and symbol psi, close brackets, is a well-formed formula. That's rule 1, or 2.1. Rule 2.2 is that brackets phi or symbol psi, close brackets, is a well-formed formula. 2.3 says that brackets phi implies psi, close brackets, is a well-formed formula. And rule 4 says that not phi is a well-formed formula. The idea is that a collection of symbols is a well-formed formula if and only if you can make it using these rules. So if you can make something using these rules, it's a well-formed formula. And if something is a well-formed formula, then you must be able to make it using these rules. So let's look at an example then of a well-formed formula. So let's just take some propositional variables first of all. So we'll let P and Q be propositional variables. Then P is a well-formed formula. Okay, that's rule 1. Q on its own is a well-formed formula. And again, that follows because of rule 1. Okay, now we can do something more interesting. We know that these 2 things are well-formed formulas, and we know that by rule 2.1, whenever you have brackets and then a well-formed formula, and then another well-formed formula, and then close brackets, that is a well-formed formula. So that is by rule 2.1. So I should say that WFF here always stands for well-formed formula. Of course, you guessed that. Okay, so we can do even more complicated stuff now, because we know that brackets P and Q brackets is a well-formed formula. We know that Q is a well-formed formula. So let's use, I don't know, let's use 2.4. We haven't used 2.4 yet. So not Q would be a well-formed formula. Okay, that's rule 2.4. And finally, let's do one more. So if I now have brackets and then any well-formed formula, we're going to use rule 2.3 here. And then the implies symbol, and then any other well-formed formula. So we'll use this. Then that is a well-formed formula. So we used 2.3. So this is how we build up complicated well-formed formulas by using the rules, rule number 1 and rules 2.2 through to 2.4 repeatedly. And again, let me emphasize, a collection of symbols is a well-formed formula if and only if you can make it using these rules. Okay, let's look at some more examples then. So I'm going to repeat a little bit what I said before. If we take P on its own, so P and Q are still propositional variables, and this is a well-formed formula by rule 1. Q is a well-formed formula by rule 1. P and Q is a well-formed formula by rule 2.1. P or Q is a well-formed formula by rule 2.2. And since we know P and Q and P or Q in brackets are well-formed formulas, then we can use rule 2.3 with phi as brackets P and Q and psi as brackets P or Q to show that this thing, which thing? This thing is a well-formed formula. And then finally, of course, you could do the similar sort of thing for this last example here. So you should actually do this yourself and say which rules you need to get that the thing at the end is a well-formed formula. Okay, so those are examples of well-formed formulas. So let's look at some examples of things which are not well-formed formulas. So not a well-formed formula. Okay, well, for example, if you just took P and Q with no brackets, that's not a well-formed formula. So remember, things are well-formed formulas if and only if you can make them using these rules, and you definitely can't make that using these rules. I mean, for example, it's clear from these rules that if you ever have an AND symbol in your well-formed formula, you've got to have some brackets as well. This has got an AND symbol and no brackets, so it's not a well-formed formula. And similarly, if I did something like P and Q and R in brackets, again, you can't make it using the rules. So although this expression has a pretty clear logical interpretation, it is not, strictly speaking, a well-formed formula. And we will look later on exactly how we can resolve that kind of problem. And also, any kind of crazy expression that you write down, not implies Q, R, close brackets, this is of course not a well-formed formula because you just can't make it using the rules.